Scientists trap waves perfectly, breaking a 100-year physics mystery. For almost a century, physicists believed this was impossible. A single object trapping a wave perfectly forever with zero energy loss. Now, a research team from South Korea has done exactly that. They've broken one of the oldest theoretical barriers in wave physics. And they did it using something as simple as a cylinder. Back in 1929, Nobel laureates John von Neumann and Eugene Wigner proposed something radical, that waves could be trapped indefinitely, even inside a system where escape is possible. They called this a bound state in the continuum, or BIC, a kind of wave whirlpool in the middle of a flowing river. The idea fascinated generations of physicists. But for decades, it was believed that BICs couldn't exist in a single particle. They needed complex structures, perfect symmetry, or artificial materials. Now, a joint team from Postec and Genbuk National University has turned that belief upside down. They used quartz cylinders, small rods just a few centimeters long, and arranged them into a mechanically tunable system. By adjusting how these cylinders touch, they controlled how mechanical waves behave at the contact points. And then it happened. Under a special alignment, wave got trapped, completely confined inside a single cylinder, with no energy leakage. Imagine tossing a stone into water, but the ripples don't move. They just vibrate in place forever. That's exactly what this experiment achieved. This isn't theory anymore. This is real. And the results were stunning, meaning the energy stayed trapped for a long time. Their setup reached kFactors over 1,000. Incredibly efficient system. But the team didn't stop there. Connected many of these cylinders in a chain. The result? A new phenomenon called a bound band in the continuum, or BIC. In this case, the trapped waves extended across the entire system, but still didn't disperse. The wave energy stayed put. It's vibrating in place along the chain. This is like a musical note being played across many instruments, all holding the same tone, without fading. Why does this matter? Because this discovery could lead to ultra-sensitive sensors, and even energy harvesting devices, where waves stay locked in, doing useful work instead of fading away. As Professor Jun-Suk Roh puts it, greater than we've broken a long-standing theoretical boundary, and in doing so, opened the door to an entirely new wave of technologies. Sometimes, science takes a century to prove an idea right. But when it does, it changes everything. Subscribe for more breakthroughs from the edge of physics and engineering.